Welcome to this session. I'm Ramesh, Assistant Professor in the Department of Aerospace Engineering, SNS College of Technology. Today I'm going to discuss in the subject rockets and missiles about the topic payload ratio as well as the mass fraction in rockets. Let's see one by one. First of all, we know what is payload ratio, what is payload as well as mass fraction. These things we should know in on what way the things are used in the rocket systems. So payload ratio in rocket systems is defined as the ratio of the payload mass to the initial total mass of the rocket as it lifts off. It indicates how much useful load, such as satellites, scientific instruments, astronauts, or cargo, can be arrived by the rocket compared to its total launch mass. Mathematically, payload ratio is expressed as the payload mass divided by the gross liftoff mass of the rocket. A higher payload ratio means the rocket is capable of carrying more useful payload efficiently. However, in practical rocket systems, the payload ratio is usually very small because a major portion of the rocket mass is occupied by propellant required to overcome the Earth's gravity and atmospheric resistance. Payload ratio is an important performance parameter in a launch vehicle design because it directly affects the mission capability, launch economy, and overall efficiency. Engineers continuously attempt to improve the payload ratio by using lightweight materials, efficient propulsion systems, optimized structures, and advanced staging techniques. Mass fraction move to the mass fraction in rockets refers to the ratio of the propellant mass to the total initial mass of the rocket. Okay, mass fraction is in the rocket refers to the ratio of the propellant mass to the total initial mass of the rocket. It represents the percentage of the rocket's total weight that consists of fuel and accessories. Since rockets require enormous amount of energy to achieve the orbital velocity, large fraction of the rocket mass, which is usually dedicated to propellant. In many launch vehicles, the propellant mass may constitute more than 80% to 90% of total rocket mass. Mass fraction is a crucial parameter because rocket performance strongly depends on how effectively propellant is utilized. According to the rocket equation, higher propellant mass fraction generally enables the rocket to achieve greater velocity. However, increasing the mass fraction also it creates the structural and design challenges because the rocket must still support the engines, tanks, payload, and control systems as well as the thermal protection components also. Therefore, engineers aim to maximize the propellant mass while minimizing structural weight. Both the payload ratio and mass fraction are closely related to rocket efficiency and mission success. A good rocket design requires an optimal balance between payload mass, structural mass, and propellant mass. If the structural mass becomes too high, the rocket loses efficiency because additional fuel is needed to lift unnecessary weight. Similarly, if the payload ratio is too low, the mission becomes economical inefficient. Multi-stage rockets help improve both the payload ratio as well as the effective mass fraction by discarding the empty stages during flight, thereby reducing the dead weight and increasing the acceleration efficiency. These parameters are fundamental in the design and analysis of launch vehicles, ballistic missiles, and space transportation systems because they determine the rocket's ability to deliver payloads into orbit or deep space trajectory. Then we will move on to the importance in rocket performance. The rocket performance is one of the most important aspects of rocket and space vehicle design because it determines the ability of the rocket to successfully carry payloads into the desired orbit or trajectory. Rocket performance refers to the overall efficiency and the capability of the rocket in terms of thrust generation, velocity achievement, payload carrying capacity, fuel utilization range, and mission success. The importance of rocket performance arises from the fact that rockets operate under extremely demanding conditions where a large amount of energy are required to overcome the Earth's gravity and atmospheric resistance. Even small improvement in the rocket performance can significantly increase the payload capacity, reduce launch cost, and improve the mission reliability. Therefore, aerospace engineers carefully analyze the performance parameter during the design and the development of launch vehicles and the missile systems. One of the major reasons rocket performance is important is its direct influence on payload delivery capability. A high performance rocket can carry heavier satellites, scientific instruments, communication systems, as well as astronauts into orbit more efficiently. Since payload capacity is a critical factor in commercial, military, and scientific missions, improving the rocket performance allows more equipment and resources to be transported in a single launch. This reduces the number of launches required and lowers the overall mission expenditure. In satellite launch missions, better rocket performance enables the satellites to be placed into higher or more precise orbits, improving communication coverage, navigation accuracy, and observation capability. Rocket performance is also essential for achieving the required mission velocity and range. To place a spacecraft into Earth orbit, the rocket must achieve the orbital velocity, while the interplanetary missions require escape velocity and additional trajectory corrections. The ability of the rocket to generate a sufficient thrust and maintain the acceleration determines whether the mission objectives can be achieved successfully. High performance propulsion systems provide greater specific impulse and better fuel efficiency, enabling the rockets to travel further with reduced propellant consumption, as well as the it is especially important in deep space exploration in missions where fuel availability is limited and mission duration is very long. Another important aspect of rocket performance is fuel efficiency as well as mass optimization. Rockets carry their own fuel and oxidizer, make them extremely heavy during liftoff. Efficient rocket performance ensures that the available propellant is utilized effectively to maximize the velocity and payload capacity. Parameters such as thrust to weight ratio, mass fraction, payload ratio, and specific impulse are carefully optimized to improve overall efficiency. Multi-stage rockets further enhance performance by discarding empty stages during flight, thereby reducing the dead weight and increasing acceleration. So that's all for today's class. We have seen about the importance in rocket performance in this class. We will see in the next class in a different topic. Thank you all.